Hi guys, this is for Module 5.1, exploring what makes triangles congruent. Our essential question, how can you show two triangles are congruent? Well, basically we're just saying, well, how can we tell that two figures, in this special case, triangles, are, well, identical, okay? Our answer, show that corresponding sides and angles, okay, are congruent. All right, so it's not just about the sides, sometimes we can use angles as well. For example, if you had a tent and he was 2 meters along this side of the tent and 2 meters along this side of the tent, and had an upper angle of about 60 degrees. And then all of a sudden, you had your friend over here, and he set up his tent. And then it was also, sorry, it's a terrible tent, but his sides here were also 2 meters, and then his angle was also at 60 meters. Chances are you're probably going to look over him and go, hey, Jim, our tents are the same, man. Where'd you buy yours? And he's like, oh, I bought it at your place, man. It was when you bought one, I bought one. And then you guys realize that two tents are the same. They are congruent. Okay, so this is triangles. Okay, but basically it's saying you can compare triangles with their angles and with their sides. All right, CPCTC. I know that we did CPCFC, and the only difference here is instead of figures, okay, we're dealing with triangles. Nice. So basically, CPCTC is this. If two triangles are congruent, okay, then the corresponding parts of the triangles are congruent, CPCTC. All right. So if the triangles are congruent, then CPCTC is applied. All right. Now, the statement sometimes is referred as this, just the acronym CPCTC. Now, the converse can be stated as the following. So if you have CPCTC, therefore, if all the sides, the angles are all congruent to one another for these triangles, then those triangles are congruent. Okay, so basically, remember that the converse just flippity flip. All right, so instead of if P then Q, it's just saying, well, if Q then P. All right, that's the converse. All right, deciding if triangles are congruent. Example 1. So first things first, biconditional is a statement that can be written in the form of if P and only if, P if and only if Q. All right, so P if and only if Q. All right, so basically it says in this situation for CPCTC, it would be all the parts, all the angles have to be, correspondingly congruent in order for those triangles to be congruent. But if you have one little piece that's off, it's not going to work. Okay, so we're going to get to that. All right, so looking down below, we're determining if these two triangles are congruent. I got a 30-degree angle here, as a 30-degree angle here, so we got a good part there. We got a 60-degree here, a 60-degree here. It looks like we got a 90 matching up with a 90. Okay, see how they're corresponding to each other? Let's look at their sides now. Hypotenuse, 2 meters. Okay. Let's look at their second longest side, 1.7. Second longest is also 1.7. And the shortest leg are both 1 meters. Okay, so basically, all the little parts, we have CPCTC. Therefore, these two triangles, those are triangles, are congruent. Okay, so these two triangles are congruent because all their little parts, okay, are congruent to each other. They're all corresponding and they're all congruent to each other. Nice. Also, if you think about rigid motion, it looks like we just had a rotation, okay? If I was to draw a point right here, we could also rotate and you would see that they can map onto each other perfectly. All right, example 2. Again, we're determining if these two triangles are congruent. So let's take a look. They didn't give us any angles, so we're just going to have to look at the sides, all right? I see a 7.9 here. I also see a 7.9 here. Okay, so those two sides look like they are congruent to each other. What about their longer side, 12.1? 12.1. Okay, so we got two sides that are matching. Okay, what about this 8.5? Whoa. Whoa. Hey, Jim, what's wrong with your tent? Oh man, they messed up on the manufacturer. Yeah, Jim, your tent's messed up, man. Get that replaced. So as you can see, those two guys are not equal to each other. Okay, so we do not have CPCTC because if it's only going to be congruent to each other under CPCT, say that 10 times fast, CPCTC, you're only going to have that if and only if all the sides and all the angles are congruent. We don't have that because that 8.4 is not 8.5. Okay, so these guys are not, oops, sorry. These guys are not congruent. Okay. So again, you could be like not congruent. You could also say triangle ABC is not congruent to triangle DEF since BC is not the same as EF. So that would be the most practical way of explaining it. Wow, what is going on with the touchscreen? There we go. There. Okay, so that would be the shortest way of saying it in a geometric presentation. All right, your turn number 1. So determine whether the given figures or given triangles are congruent. So again, you have angles, you have sides. We have little tally marks. Again, tally me bananas. Tally marks basically just mean that this guy's the same as this guy. So you got 4 sides that are all congruent to each other. That's nice to know. Okay, so again, discuss it and see what you do. Or what you get, I guess. All right, your turn number 2. Determine whether or not these triangles are congruent, and then make sure you explain, okay? So it looks like they only gave you one side, but they gave you a whole bunch of angles. Okay, so maybe the angles will help the most. Just let me know. All right, applying properties of congruent triangles. So example 3, find the value of the variable that results in congruent triangles. Okay, so now we're applying this. So we're told, apparently this is an assumption that these triangles are congruent. Okay, so they're like, hey, Jim, I want to build a tent just like yours. Oh, okay, well, let's make sure you got the right angle. And basically, you already measured this guy's a 45. Hey, Jim, you got a 45? Yeah, I got a 45 right here. Hey, Jim, you got a 55? Yeah, I got a 55 right here. Um, wait, how many inches do I need to use here to get the right angle? And you're like, oh, gee, Jim, let me find out. So we do know that all the angles of a triangle add up to 180, right? So triangle sum theorem, okay? Now, by that logic, we have, again, the measure for angle K plus the measure for angle J plus the measure of angle L have to be 180. Okay, that's the triangle sum theorem. Which we'll get to even further into the year. All right, so by that logic, we have a 45-degree angle for K plus the 55 degrees from J and plus the measurement for angle L, which we do not know what it is, but we know they all add up to 180. Nice. I'm going to go ahead and combine like terms. Okay, and again, all I did was substitution here. I'm going to combine like terms, and I'm going to get, it looks like 100. Very nice. Plus whatever the measure is for L. We don't know yet, but we're almost there. And again, that was because we combined like terms. Sorry, I ran out of room right there. I don't know why I'm not working at the bottom. All right, subtraction property. Very good. Subtraction property of equality. We got angle L equaling 80. Very nice. All right, that means what? That means that this guy, angle P, the measure for angle P, has to be 90 degrees as well. All right, so they only gave us this expression, so we're going to go ahead and use the expression to now solve. So 5x plus 30 should be giving us, oops, sorry, I don't know why I wrote 90 there, 80 degrees, my bad. Sorry, it's late. There we go. 80 degrees, there we go. Much better. Quick save. All right, subtraction property of equality. And that's equaling 50. Nice. Division property. Very nice. X equals 10. All right, so that's just one way of solving it. Now, writing this all out does help and make sure that you don't make too many mistakes. But notice how we're using the idea of CPCTC, knowing that these guys are being told that they have to be congruent. Therefore, that's how we solve for the missing variable. All right, example 4. So find the value again. So let's see, they give us nothing but sides. Okay, good. And here's our expression right here. Okay, so let's see. This guy's congruent to this guy. I'm just checking the sides. This guy's going to be congruent to this side. Okay, very nice. That means by process of elimination that these two sides have to be congruent to each other. So 2y plus 20 millimeters, okay, I'm not going to forget that, should equal 36 millimeters. All right, so let's use subtraction property, basic algebra, equals 16, division property, and y equals 8. All right, so that is the value. All right, so again, I'm going off the idea of congruency with CPCTC. There we go. All right, your turn number 3. Okay, go ahead and do what I just did. We're solving for x. So what is that angle corresponding to? So try to figure out that first. Let's see, we got a 25 here. He's matching up with another 25, right? So trying to figure out who's corresponding to who, and then that should be leading you into the solving process. Also, notice how they did not give you the angle measurement here. So again, you have to know that all the angles in your triangle, so they have to add up to 180. So again, start here to find out what you're going to set your expression equal to, okay? So again, all the triangles have to add up to 180, triangle sum theorem, okay? Start there, substitute, and then that should help you lead into finding the 180. Then once you find this value right here, you'll know what to set up your expression equaling to, okay? All right, your turn number 3. Same situation, except now you're just dealing with the sides. So which side is corresponding to which side? So again, you have a 15 here, okay. Oh, we have a 15 here. He's corresponding to that guy right there, okay. So basically figure out who's corresponding to who, and then set them equal to each other. Solve for y. All right, guys, have a great day, and let me know if you have any questions. Good luck. May the fork be with you.